So this video is going to go over how to graph when you have to use technology, and I'm going to focus on using Desmos. So please go to Desmos and click on the graphing calculator as opposed to scientific or for function. So it's literally this simple on Desmos. You just type in the function. You can type y equals if you want, or f of x. It's up to you. To put an exponent in, you use the caret, which is shift 6. Make sure that you either click here or use the right arrow key to put minus 4x. Make sure that what you type is what you see on your paper. And you can see it beautifully displays everything. So in the directions, it basically says use your calculator or Desmos to graph the following, sketch the graph, find the minimum, maximum, x-intercept, y-intercept, everything you need to make a highly accurate graph. Well, on Desmos, all you have to do is hover. -2, 0, 1.155, 3.079, 0, 0, 1.155, comma, -3.079, and 2, 0. If you need a better graph, you can either zoom in with this, or you can do it a little bit more precisely with your scroll mouse. Beautiful graph. So why don't we start with that, and then I'll go over what it would be like on a TI or Casio calculator, which on the SAT, obviously you'll need to know how to do that potentially. So what we're going to do to make the graph is we're going to graph it using an axis. There's a lot on here, so I'm going to just go by 1/2. So here I will put a 1, meaning each tick mark is 0.5. So we'll just fill that in. Here we'll do the same thing. And the same thing over here. So then what we do, right, after we do that, is we're just going to graph, and we might need to go back and write down what Desmos showed us. You know, Desmos showed us that we have -2, 0, 1.155, 3.079, 0, 0, 1.155, -3.079, and 2, 0. And if we want to know what these endpoints are, see how the endpoints are -2 to 2, what we would do is we would just hit enter and say, hey, Desmos, what is x equals -2? And it tells you, okay, boom. And then I can say, well, hey, Desmos, what is x equals 2? And it tells you it's 2, 0. Notice that the interval is inclusive, so that those will count as x-intercepts or roots. So we just get out our pencil or pen, and we just start graphing the points that we saw. All right, and then -1.155, 3.079, just a little bit past -1, a little bit above 3 will do. It's just an approximation. And then what we do is we draw a nice curved graph that looks like the shape that we see on our technology. Now, to do this on a Casio or a TI, it is more complicated and is going to take you longer. And the reason we go over Desmos is in Virginia, we can use it on the SOL, Standard of Learning test. So here are the screenshots for a TI calculator. You type in the function into Y1, you then graph it, you hit second calc, you hit graph to graph it, then you hit second calc to find the min or the max. Then you go and hit second calc again, and you use the value feature to find the y-intercept, and then you hit second calc to find the x-intercept. It is called root on the TI, and you have to do it 3 times. On the Casio, it's very similar. You go to menu, you type it into the function, you then hit the graph menu, and then you follow gsolve to find these same items. All right, so our job was to make that graph and then go over the same questions we did on the front here. So I have copied a picture of the graph here, and we can go over what has happened. So again, if you need a little bit more help on the calculator, I'm sure there are videos that you can watch on how to do that. So here, what we're going to do is we're going to look at, is it odd, even, or neither? It is symmetric to the origin. You can clearly see these points being the same, but positive and negative, clearly symmetric to the origin, so it is odd. It is going upwards here, so it is positive, and you can see the full graph here, so you know it's going upwards, so it's a positive. It has 1, 2 turns. You add 1 to the turns you see on the graph to learn that it's a third degree, or x to the third problem, called cubic. You then would look at the x-axis to find any roots. Keep in mind, I think I forgot to mention, on a Casio, these are called zeros, just as I've mentioned, and on a TI, they're called roots. They are synonyms. So we can clearly see that we have a root at -2, 0, and 2. They are real because I can see them. And this number right here, right? So this number here matches everything in this statement So there's nothing hidden from view. There's no complex. If I only saw one root, right? If it only crossed once, let's say I had a cubic that looked like this, right? That's only one root. So how many would be imaginary? Well, if I only have one root that I can see and there's supposed to be 3, then there would be 2. And keep in mind that complex roots always occur in pairs. So to rewrite this as intercepts, we write it as -2, 0, 0, 0, 2, 0. The y-intercept is also 0, 0. You see that happening a lot. It has to happen with an odd function because it has to go through the origin to be odd. The function would be to reverse this and make this x plus 2. 0, 0 would be x plus 0, but that's not appropriate. It is not simplified, so just x. This would be x minus 2. This has no exponents, unlike the 3 examples I did previously, because there's no double roots, right? These are all linear single roots. The domain goes from here, so beep, goes from -2 to 2, solid dots, which come from the fact that it gave me a bracket. Be careful if one of these was a parentheses, it would go right into here as well. The range starts at the bottom, beep, and it's slightly off because it's not -3 to 3, it's actually -3.079. And that's how I would know that a student was having trouble, that they didn't actually look at technology, because of the fact that they didn't include those decimals, right? Those decimals needed to be included because they came from the technology. And so the domain on the left side stops at -2, and its output value is 0. And on the endpoint here, it goes to 2 and is 0. Yes, the range is -3.079 to 3.079, but those values, they are not at the endpoints. They are in the middle of the graph. So relative minimums, I have one at -2, 0. And if we want to stay consistent, that one should stay first because they do come in order. So give me 1 second to adjust that. So the first one that we encounter is the endpoint, -2, 0. The next one we encounter is this point right here. This is also a minimum, so 1.15, -3.079. My maximums are here, 1.155, 3.079, and 2, 0. The reason that this is a maximum is it goes from increasing to decreasing. This one goes from decreasing to increasing. So let's talk about that. It may help some people understand how this works. So we are increasing here, and we are increasing here, and then we are decreasing here, and that change is what provides the minimums and maximums. Notice here it's nothing and then goes up, so we're changing from nothing to increasing, so that would be a maximum, and this one is increasing and then stopping. So I mean, think about a walk. If you were walking here, this is a low point. You started low, you hiked up a mountain into a valley, and then you came back to a high point. So thinking about it as a hike really helps. So once I do that, what I'm going to do is I am going to take a look at which of these is the largest or smallest. The absolute minimum is the one that has the lowest, smallest output, and that one would be the second one, right? So you can clearly see here that this number is smaller than 0, so that's my absolute minimum. And here, remember, I'm looking at outputs for this. This one is bigger than 0, so that's my absolute maximum. You can already see the increasing interval here, right? So -2 to this point, which is 1.155. We're also increasing from 1.155 to 2. We use a solid bracket there because they are defined points. Please keep in mind that shared points are always parentheses because they're shared. They can't be both increasing and decreasing at the same time. So it's decreasing from -1.155 to 1.155. And that includes parentheses because these values, look, I mean, they're shared. They're here and they're here. So you can't put a bracket on one. How could it be increasing and decreasing at the same time? So if that confuses you, I know some people have trouble with, is it bracket, is it parentheses? Endpoints get brackets with increasing and decreasing. All right, I hope you enjoyed this lesson in this video, and I hope you have a good day today.